Dear friends, welcome to EPG Pathshala. I am Dr. Nitesh Goyal from DAV College, Chandigarh. I am going to present before you the 18th module titled Basics of Sampling under the paper Tourism and Hospitality Research. The module will cover the following topics: Introduction, the sample survey, implications of a sample design, process of sample designing, criteria of selecting a sampling procedure, sampling errors, characteristics of a good sample design, and finally, the summary. Dear friends, after the completion of this module, you will be able to understand the sample survey, understand the implications of a sample design, identify the steps to be undertaken in sample design, understand the criteria of selecting a sampling procedure, sampling errors, and characteristics of a good sample design. First of all, dear friends, I would like to give you a brief introduction about the topic. Friends, to understand the whole process of conducting research, knowledge of the concept of sampling and its application in research are a precondition. In our daily life, without knowing, we do apply some of the sampling techniques like judgment of the quality of whole of the wheat bag by just checking a few grains in your palm, or checking the quality of a cloth by rubbing hands at any one single part of the whole cloth. On the basis of this observation of a small part of the whole product, one makes the decision to buy the whole product. Thus, in our daily life also, we use sampling in routine. Hence, this module is aimed at making the learner aware about the different types of sampling and sample designs. Sampling is the process of selection of a part of population, and that part truly represents the whole population. In the preparation of drawing a sample, many questions may arise in the mind of the researcher, like, is there a possibility of making procedural errors that may influence the results but are not related to the sample itself? Is there any possibility of making errors in sampling? How to determine the size and the accuracy of the sample result? Friends, every item under any piece of research study forms a population or say universe. In other words, all the items that are being studied are together termed as population or universe, including each and every item of whole of the population for the study at hand is called as a census survey. The best example of a census survey is population census, wherein data is collected from each and every citizen of the country, and this population census method is adopted across the globe. In case of a census survey, it is generally presumed that when all items of the population have been included, there is no chance of anything left and highest level of accuracy can be achieved. However, this is not that easy in the practical sense, as the smallest amount of biasness on part of the researcher or investigator in a census survey will acquire a larger size as the number of observation is also large. Also, there is no predefined method of examining the element of biasness or its extent except through a resurvey, which is quite cumbersome and time consuming and also involves a lot of financial resources. Thus, at the time when the magnitude of the study is massive, the census survey method becomes difficult to apply as it demands a large amount of human and financial resources to conduct the survey. At times, this method actually becomes almost impossible for a researcher to fund such kind of study. Possibly, it is the government institutions only that can afford to undertake the complete enumeration, as it has all the required resources that may be required to put in. However, it is not the case that government undertakes census survey for every type of research it conducts. Even the government tries to avoid using it, and population census is conducted once in every 10 years. Besides, sometimes it is also not practicable to investigate each item of the target population, and many times it is indeed practical approach where adequately accurate results are drawn by studying just a part, which is called as a sample out of the total population that represents the whole population. In such a scenario, the researcher should never go for census survey, but instead opt for studying a part of the population, that is the sample only. However, it is significant to highlight here that when the population size is small, it becomes inappropriate to go for drawing a sample out of the population. In the real life situation, a lot of consideration is given to the time and cost involved. Thus, cost and time involved in sample survey and census survey is compared and the better option is selected. Selection of sample command utmost care and be drawn in such a manner that is truly representative of the population. The selected part of the respondents constitutes what is statistically termed as a sample, and the selection process of drawing the sample is thus termed as the sampling technique. The survey so conducted with the help of the sample is thus termed as sample survey. It is now very much clear that a sample design is a predetermined plan for drawing a set of sample out of a given universe or population. Thus, the procedure or the technique adopted by the researcher for selecting the items out of the population for the sample can be termed as sampling design. Sample design may also specify the total sample size, that is, the total number of items to be taken for the sample. Sample design is the first step in the process of data collection. There are many types of sample designs from which a researcher can choose one. Some of the sample designs are relatively more precise and thus easier to adopt as compared to others. Hence, the researcher must select a sample design out of the existing designs or prepare his own design that is reliable and appropriate for the research study at hand. There is a proper procedure to prepare a sample design and should be followed very cautiously. Thus, at the time of developing a sample design, the researcher's utmost attention should be towards the following points. First, the population. The first and the foremost step in developing a sample design is to very clearly define the target universe or the population to be studied. The target population can be finite or infinite. In the first case, that is the finite population, the units of the population are known or countable, that is, they are finite. However, on the other hand, when the units of the population are not known or cannot be counted are called as infinite, that is, the researcher is not aware of the total number of items in that very population under study. The total number of residents of a city or town, the number of students in a college or a university are few of the examples of a finite universe, where total number of the constituents of the universe can be counted. Whereas the numbers of stars in the sky, total audience of a TV reality show, total grains or crops in the field, etc. are the examples of infinite universe, where the total number of units of the population cannot be counted. Second, the sampling unit. After deciding upon the universe, next step is to take a decision regarding the sampling unit before the final selection of the final sample. This sampling unit may have some geographical boundaries based on different criteria like state, district, town, etc. or maybe at more narrower level like a building such as a house, a flat, etc. However, it need not only be a geographical area but may be a social unit like a family, a club, a school, etc. or just an individual only. Now the researcher may decide to select one or more of such units for the present study at hand. The third thing is the sample frame. Sample frame is also known as source list. It is a list or a frame from which the sample is to be drawn. This list contains the identity of all the items of the universe. The sample frame or source list prepared only in case if the population is finite. In case of infinite population, preparing a source list is not possible. In case the complete list is not at hand, the researcher has to make an extra effort to prepare this list by himself. However, such prepared list or sampling frame should always be complete, accurate, reliable, and more important, should be appropriate. It is very important that the source list presents a true picture of whole of the population to the extent possible. The fourth thing is the sample size. After preparing the sample frame, it is decided that what should be the total number of items to be taken from the universe to form a sample. This is one of the major hurdles before any researcher. It is extremely difficult and important to ensure that the size of sample should be appropriate. That is, neither be too large, making it difficult to manage, nor too small, leaving it to be less representative of the whole population. Thus, always ensure an optimum level. A sample size can be called as optimum only when it is capable of fulfilling the requirements of efficiency, representativeness, reliability, and flexibility. The size of population will also affect the size of the sample and are positively correlated. That is, larger the universe, larger will be the sample size, and smaller the universe, smaller will be the sample size. The total budget allocated to the research also influences the sample size. This again is positively correlated. A larger budget can enable the researcher to opt for a larger sample. The fifth thing relates to the parameters of interest. While preparing a sample design for the study, the researcher must take into consideration the question of any parameters pertaining to the certain universe which are of interest to the researcher. For example, the researcher may be interested in examining the category of people with certain specific features or attributes within the population, or the researcher may also like to estimate some average concerning the said universe. There may also exist some important groups within the groups, termed as subgroups, about whom the researcher possibly would like to examine. All these things have a significant impact upon the sample design that is to be finally decided upon and accepted. The next thing is the sampling procedure. Sampling procedure is the final step in sample design. It undertakes the decision on the type of the sample the researcher will be using for the study. It is concerned with the decision on selection of the techniques to be used in selecting the items for sample out of the population. There can be a number of techniques that can be followed, out of which the researcher has to choose one for his study. Now, the question arises of which techniques to be chosen. It becomes important to choose only that technique that suits best in terms of applicability, feasibility, costs involved, and it leads to minimum error in sampling. Now, this part of the module discusses the ideal criteria for selecting a sampling procedure. In any research, there are two types of costs involved, direct and indirect. Direct costs pertain to the collection of data and then analyzing it. The indirect costs are the costs that pertain to some wrongdoings, that is, large sample error, wrong inferences drawn, etc. Researcher must bear in his mind the two major reasons for incorrect inferences like systematic bias and the sampling error. Systematic bias is a bias that results from errors that have occurred during the sampling procedures and cannot be avoided or totally eliminated by even increasing the sample size. At best, the causes responsible for such errors can be detected and corrected. Generally, a systematic bias is the outcome of one or more of the following factors. First, biased sampling frame. If the sampling frame is biased, that is, it does not present a true and fair representation of the population, it will definitely show some sort of systematic bias. Secondly, imperfect measuring device. If it is found that the measuring device adopted in the research persistently shows error, it will further result in systematic bias. In a research survey, the systematic bias usually emerges if the tool of questionnaire is biased or the researcher himself is biased. Thus, if the physical measuring device itself is found to be defective, there are fair chances of occurrence of systematic bias in the data so collected. Third, non-respondents. If due to some reason the researcher is unable to collect data from each of the individual initially included as a part of the sample, there may arise some systematic bias. This is due to the reason that in such a case, the likelihood of establishing contact or receiving a response from an individual is related with the measure of what is to be estimated. Fourth, indeterminacy principle. It has been observed that the individuals behave differently when they are kept under some sort of observation as compared to what they behave when kept without any observation on them. For instance, if inmates of a jail of a certain city are aware that they are under some kind of observation for the purpose of deciding of their performance evaluation criteria based on their behavior, sincerity and discipline shown by them, and accordingly marks will be awarded to them, the inmates will usually tend to behave in a better manner with full discipline. Thus, indeterminacy principle may also be cause of a systematic bias. Fifth, the response error. A systematic bias in many inquiries may also arise due to the natural biasness shown by the respondents at the time reporting of the data. There is generally tendency of the respondents of not disclosing the real information about their income when asked, especially by some government agency. It has been very common to observe that people would understate their income if asked by some government agency, but they tend to overstate the same if asked for social status. In general, it can be stated that instead of giving the correct information, people tend to give such information that they deem to fit for giving, whether it is overstated or understated. The sampling errors occur randomly and are equally likely to be present in both the directions. They would act as compensating the extremes, and the final estimated value of such errors that comes out becomes 0. Chances of sampling errors are directly proportionate to the sample size. That is, sampling error decreases with the decrease in sample size, and sampling error increases with the increase in sample size. Sampling error can be measured for a given sample size and a given sample design. The measurement of sampling error is usually called as the accuracy of sampling plan. If the sample size is increased, the accuracy in the sampling also tends to increase. However, increasing the size of sample may not always necessarily increase the accuracy level, as large sample size also suffers from some limitations, like increasing the sample will also increase the cost of data collection and also increases the chances of systematic bias. Thus, the better solution to increase the accuracy is found in selection of a better sampling design only, so that it produces relatively lesser chance of sampling error for a given sample size at a given cost. In practice, however, researchers opt for a not so accurate design as it is more flexible and comparatively easier to implement, and also because of the reason that systematic prejudice, if any, can better be controlled in such sample design. In simpler words, the researcher should pay utmost care while preparing a sampling procedure so as to make sure that the procedure adopted for the study results in lesser sampling error and also helps to control the systematic bias in a more effective manner. From what all has been stated till now, following is presented the list of some of the key characteristics of a good sample design that a researcher should always keep in his or her mind while deciding upon the sample. Firstly, a sample design should bring out such a sample that presents the true and fair picture of the whole population or universe. Secondly, a sample design should be such that it leads to least possibility of having sampling error. Thirdly, a sample design should be realistic in a sense that can be applied practically and is viable in the terms of the money involved for conducting the study. Fourthly, a sample design should be designed in such a way that systematic bias can be controlled in a more effective manner. Fifthly, a sample design should be such that the outcomes or the findings of the study conducted on the sample can easily be applied for whole of the select universe with a high level of confidence. Friends, let us now summarize the whole lecture. Sampling is indeed a powerful and strong tool for accurately measuring opinions and characteristics of a population where reaching to whole of the population is not feasible. However, there is a great chance of it getting misused by the researchers who do not have full understanding of the tool and the limitations of various sampling procedures associated with them. There is a set sequence of preparing a sample design which starts from defining of the population to the techniques of drawing the sample out of it. A sample design may prove to be fatal if it suffers from sampling errors. These errors lead the researcher away from the real opinion of the whole population. Thus, a list of features is provided if kept in mind by the researcher can produce a quality sample design for any research study. A good sample design may have a lot of features, but all should help bring the sampling error to the minimum and then only be called as a good sample design. A sample design itself is not sufficient if not prepared with due diligence and care. Sample design forms the part of the strong foundation of any research study, whether it is at large scale or the small scale. Thank you.